number 48, we're looking at three different investment opportunities. The first is a 5-year ordinary annuity of $10,000 per year. The second, investment B, is actually it's a 6 years. Investment B is a 6-year annuity, but it doesn't start. The first payment doesn't occur until the end of the 5th year. And the third investment opportunity involves receiving $10,000 1 year from now, $50,000 6 years from now, and $10,000 10 years from now. So these are our alternatives. It says to assume a 20% discount rate. So we're going to value each and see which one is worth the most. Using our calculator, the present value of the first one, we could just say it's an ordinary 5-year annuity. So set n equals to 5. The interest rate, of course, is 20 per year. It's an annual annuity, so the interest rate would need to be annual. Annuity payments are $10,000, and future value is 0, so we're not using that register. Solving for present value, I believe we get 29,906. Second option, we call it PBV. Actually, it's going to be a few steps to find the present value of that 6-year annuity that doesn't start until the end of the 5th year. That pays at the end of years 5 through 10. There's 2 steps. First, it's a 6-year. There's 6 payments, so it's a 6-year annuity. So first, we're going to value a 6-year annuity. Everyone dealing with annuity streams, we always set n equal to the number of annuity payments. So n is equal to 6 in this case. Interest rate is still 20. The payments are 10,000 again. So actually, you didn't need to change PMT or I. And future value we're not using. All we need to do there is change n from 5 to 6 and compute present value. This present value is going to be, the present value of an ordinary annuity. If we put ourselves in the timeline, well, we have to put ourselves in, for this to look like an ordinary annuity from our perspective, with the first cash flow occurring 1 year from now, we'd have to put now at some point in the future. Okay, first, let's just get this number up. It's going to be 33,255. The present value of the 6-year annuity. And like I said, on the timeline, the cash flows are occurring 10,000 at the end of 5 years from now, 6 years from now, and so on. So if we put ourselves right here, okay, we're right there at 4. We're supposed to be a stick figure. Remind me not to do that again. We put ourselves right here in the timeline at the end of 4 years, with the next cash flow occurring 1 year from now, now being t equals 4 years. Okay, then it looks like an ordinary annuity, right? So when I found the present value of that 6-year annuity, I'm finding the value of that annuity at this point in time. That's not time 0, that's time 4. So I need to discount that back 4 more years in order to compare it to my alternative investment A, because that was a time 0 value. So I have to convert investment B into a time 0 present value as well. So the value of that thing today, call it step 2. You could just, well, 2 ways. You could set n equal to 4, set future value equal to this 33,255. Interest rate, of course, is still 20. Set PMT equal to 0. And you could just count it back to the present that way. Put those in your calculator and solve for present value. You would get 16,037. Or, of course, you could have just done the 33,255 divided by 1 plus 20% to the 4th power. That would also give you that same number. Whichever, as far as speed, those 2 methods are about the same, I guess. So the sum of those, 33,000 32,000, whoops, I'm sorry. Okay, so that's the present value of alternative B, the second one. 16,037. Alternative C, it's almost easier to do it. I'll show you two ways of doing part C. We could do it algebraically. Present value, the total present value would be, we're getting 10,000 in 1 year, so 10,000 over 1 plus 20% of the first power, which is itself. And the second cash flow is 50,000 at the end of 6 years. 50,000 divided by 1 plus 20%. The sixth power will be the present value of that second year, that second cash flow, the one that occurs at the end of the 6th year, all by itself. And then the final cash flow is 10,000. That happens at the end of the 10th year. So I divide by 1 plus 20%, the 10th power. I could add those up, or, and we haven't done this yet, you could use the cash flow register on your calculator. But it's not going to be real simple. It's not a simple case. Or actually, okay, there's actually three methods. One would be to find, let's set n equal to 1, I equals 20, future value equals 10,000, solve for present value on your calculator, and store that number. Then set future value equal to 50,000 and n equal to 6, and solve for present value, and store that number, press STO2, solve for this, press STO1, solve for this, and then press STO, and then the number 2. Then put 10,000 back in for future value, and 10 in for n, solve for present value, and store that, STO3, then you do RCL for recall, 1 plus RCL1 plus RCL2 plus RCL3 to add them up. Or using the cash flow register, you could hit the CF button. You know, we're going to do this a lot later. But since I started, CF0, the CF button declared its second function clear after hitting the CF button. Okay, then hit the CF button, the first number is 0, press the down arrow, so say CO1, take that 10,000, hit the down arrow, press enter, then press the down arrow button, and we'll say F01. That occurs once. The next cash flow will be CO2. Just set that equal to 0. You're getting 0 cash flows in years 2, 3, 4, and 5, so 4 times in a row. So F02 is going to be 4. F is the frequency. How many times in a row did that cash flow occur? If it happened 4 years in a row that you got 0, then alternative C. So enter 4 for frequency, then hit the down arrow button. You get CO3. The next cash flow is going to be the 50,000. So type in 50,000, then press enter, then press down arrow. That happens once. So F03 would be 1, down arrow, which is the default. CO4 is again 0. That's happening in years 7, 8, and 9, so 3 times in a row. So FO4, then 3. And then finally, CO5 is 10,000 again. FO5 is 1. If you cleared it out beforehand, then everything should be zeros after that. Then hit the NPV button. It'll ask you for an interest rate, type 20. And then press enter, then hit the down arrow button one more time. It should say NPV on your screen. Then you press compute. So that's 3 different ways of doing this I've shown you, and I've probably taken more than 10 minutes. Should get 26,700. Whether you do it this way, or doing it this way algebraically with a normal calculator, you get the exact same number, 26,700.